everyone. Can you hear me? Thank you. Yeah, today's topic is about how at Elsevier we are harnessing scientific knowledge with cutting-edge technologies and artificial intelligence capabilities. I know that it sounds very big, but I'm happy that some of the sessions we had in the morning were giving the context about data knowledge and data science, and I think that would set the context, and with that, I would go to my agenda. I will start with introduction to Elsevier because I want to create more brand about Elsevier, and that's why I thought it makes sense for me to spend some time, a couple of minutes on that, and then talk about how we are delivering impact to our communities. We are having a lot of capabilities and products. I would touch on that, and then bring in the generative AI into the capabilities that we are having. I have some examples where I would show some use cases of how these generative AI and the capabilities that we have coming together and solving some of the interesting problems of our customers. Let me start with introduction to Elsevier. To introduce Elsevier, I must start with RELX, because RELX is a parent company, and all the 4 letters of RELX represent 4 different companies there. R stands for risk, E for Elsevier, L for legal, and X for exhibitions. These are the 4 different companies. All of them are in India, and also globally we have presence. And they work on all these information-based analytical systems and solutions for the customers in those areas. I have given the website also. Please take a look at it whenever you have some time. Now, coming to Elsevier. I'm sure all of you know about it as one of the largest scientific publishers and content providers in the world. That's the very common thing that everyone says when we say we are at Elsevier. But beyond that, we have a large focus on technology. We have a large portfolio of more than 50+ products, solutions, and platforms, and web applications that are provided to our customers in the areas of research. Research, I mean academia there, life sciences, and health. These are the 3 core business that we work in. And I've also seen the presentations earlier where they were talking about health, which is very much resonating to what we are doing there. What's our mission? Because I wanted to set that there, because what we are doing is according to our mission. Our mission is to help our researchers and professionals advance science and improve health outcomes and business outcomes for the benefit of the society. Now, let's take a look at challenges in these areas. First one is related to research. We all know how important it is to invest in research, and based on the statistics we have, I could see that there is a huge investment happening in research. In 2019, the number is 2.3 trillion, and 2022, I saw that as 2.47, which means there is a significant growth in the investment happening every year, which is great to see. But unfortunately, the researchers do not have right tools and solutions to make this research more effective and be productive quickly. So that's one challenge that we are trying to address. And next one is related to the life sciences. This is basically the drug development process which I'm talking about. Again, with the COVID, we all know how critical it was to make this drugs ready quickly and vaccine stuff. But unfortunately, the drug development process is very slow, and it is very expensive, and also only 1 out of 20 trials make it to production. So that says that there is something we have to help to make this improved and make it more effective. So that is one area we are working in. And the last but not the least is related to health. Of course, health is very big domain, and there are several players working in several things, but we are focusing on medical errors, because that is one of the top 3 reasons of causes of death in the US, and we are trying to see how we can help them. So we help them to make right decisions. So I will talk about our product offerings a bit later. So put together, these are all unique challenges, and Elsevier is trying to see how we can help resolve these problems and help the society. This is our overall organization. We are more than 8,700 and of course now close to 9,000 employees globally, and we have different tech hubs. We call them as tech hubs in our terminology, and they are located in London, Amsterdam, Philadelphia, and in India, Bangalore and Chennai. And we work more in data, and so we have data scientists and technologists. So, and in Bangalore, if I have to take a minute and say about it, we started in 2021, and by now we are 300. We had seen a significant growth there, and also we are making it or planning to become 500 in the next year. We have a lot of openings. Please come to our booth and see and talk to us. And one last thing about introduction here, we don't just support our researchers, we also try to collaborate with them and help to do the research. We are partnering with the universities and labs so that we also participate in the research area. We are collaborating with Discovery Labs in Amsterdam, and where we are working on the AI-related research. And in India, if I have to talk about, we are working with IITs, IIT Mumbai, and also NIT Surathkal, to name a few. So that's how we are, and I hope it made more information you got about Elsevier. Now, I'll jump into what we are doing. So as I said, we are delivering impact to our communities by having whatever the product offerings we have. So this diagram depicts the whole picture of what we are doing, and it's in two phases, I would say. The top blue one indicates the typical research publishing workflow, and as you all know, we are very good into research, and that's the first thing we've started, and we've been doing it almost 140 years. So this has several steps. Starts with the author, and it goes through several steps, and finally the article is published. So at every phase, there are a lot of problems that researchers face, and Elsevier has developed many tools and solutions to solve these problems. To name a few, Scopus and Science Direct, these are the first steps for any researchers, because if they want to do some research and find some information, they go to this websites and take a look at it and get the related information. And the second one, the orange one that is talking about the knowledge bases, we don't just have the research knowledge we have, we also get a lot of third-party vendors who are providing the content related to all the three domains that we are working on. We have a plethora of heterogeneous databases. We try to combine these two data sets and run them through the digital platforms that we have there. We have many digital platforms. We call them as data platforms. So after the blending of this data, we really provide meaningful insights to our customers. So using those product offerings. So product offerings, I talked about research already, and there are many more actually. If you go and search in Google, you would find about these products. I want to talk about a bit on the life sciences, which is again a very important React6 and Forma Pendulum we have. And in health area, we try to help the clinicians using the clinical key care plans kind of products. And we have health education. In that, we have products like HESI, 3D for anatomy. This is very interesting product where Elsevier is the first one to really provide the anatomy of a female. Always, I think, otherwise, only male anatomy was provided, and this is the first time in the world Elsevier has provided the 3D anatomy for the women. That is what we do. And to talk about AI here, in almost all these products, we've been using AI. It's not new to Elsevier, because we are doing a lot of predictions, we are doing a lot of recommendations and all that stuff. We use, to be very specific, we use the extractive AI. Extractive AI is used to make predictions. So what it does is it identifies the patterns. We have a lot of data using that pre-existing historical data that is available, and then make the predictions. So we do have models where we pass this data to these models, and then that would be providing the insights. So that's the typical flow we have. And one example I want to talk about is the Forma Pendulum. So here, I talked about the overall drug development process. And what we are trying to do here is we try to predict the chemical reactions much before it is run in the real world lab. So that would really help the pharma people, because they don't want to wait till the end to see what would happen when they run in the real world lab. Instead, we are providing this simulations, and we are showing them the probability. Again, there, if I have to talk about the data quality and accuracy, we take good care of. So that way, there is most of the predictions that we do are very valid. So that is the way we provide our details to our customers. This is the zoom-in version of all the different data sets and knowledge bases that we have and we use at Elsevier. So I don't want to read all of them, but it has researchers and all of them related to the research. And we have life sciences related, which is trials, reactions, substances, and so on. And then we have drugs and all, which is related to the health. So this is the volume of data we have and we use and we process. By the way, this is 780 billion is the number. Any guesses what it could be in the context of Elsevier? I couldn't hear anybody. Data points? No, not really. I will tell this. It's nothing but the annual search requests that we receive. So if I have to compare it with Google, because Google is the very renowned search engine, it's almost 65% of the traffic of Google annually, whatever it processes, is coming to Elsevier. So that is showing the volume of the data we have and also the search engine that we have. So that's about it. And now, this is the technology approach at Elsevier. I want to drill down how we are doing this data mining, data processing, and all that stuff. So I told about the data which we get in different formats. It is either structured or unstructured. Structured is some of them, if I have to call some of them PDFs, we have XMLs, we have raw data in the papers, images sometimes, and also we have XMLs and JSONs. So many different types of data we receive. We translate them into whatever the format that is expected by our data platforms. The whole funnel is the data pipeline. We call this as data platform. And finally, we produce meaningful insights to our customers. Again, I told about quality and accuracy there, which is very important. We always aim for 99% precision and more than 97% recall, and that is always known to our customers. So that is the quality we will have. And I'll just explain a minute about what is that we are doing. So we have multiple steps in this data processing. We start with entity extractions, normalization, and annotations that is required to identify the entities. When I say entity, I'll just give an example. Let me take an example of an article. Article has so much information. So starting with article, which is one entity. We have an author, which is an entity. We have a reference, which is another entity. We have organization, that is different, another entity. So we try to identify the entities that are there in that article. And the next step, we identify the relationships. Relationships is like, what is the relationship between these entities? So we use matching and linking and a lot of algorithms we have. We use a lot of data science there. This is the next step we do. And once we have this entities and relationships, we create a powerful knowledge graph. Knowledge graph shows a lot of details about the knowledge, a type of a knowledge that is maybe article or anything else. And that is in a triplet format. Triplet is nothing but subject, predicate, object. That is a standard format that we use. So in all these steps, one thing I want to say is we have been using data mining techniques. We use data science. We have natural language processing. We have AI, including generative AI, which we started talking about. And we have already implemented some of them in our applications. So our approach is so matured that once we have this generative AI coming in, it was very easy for us to plug in and do something very quickly. And we also have well-defined responsible AI principles. I've heard some of them talking about it. So we had already established that, and we make sure that we do not deviate from all those principles and guidelines. This is a sample knowledge graph that I have for the search by numbers. When I say numbers, it gives a lot of data analytics here. It gives a lot of information about the knowledge which I told. So if I have to talk about it, how many organizations are using this particular search keyword? Let's suppose it is for a particular topic. How many organizations are contributing to this? What is the value of this, whatever the topic? And what is that authors, how many authors are having this research? So all the different information is provided. So using this information, the customers can make some decisions, right? Because there are a lot of projects which we have where we really give them data. Data as a service is what we do. So what it does is they give some raw data to us, and we provide them meaningful insights. Based on that, what they can do is they can realize, is that the right investment I'm doing, or I have to do something else? So these are the kind of insights we provide to our customers. Yeah. Now I want to jump into the generative AI capabilities. So as I said, we have started using it. I'll talk about how we are experiencing and experimenting generative AI at Elsevier. This is depicting the overall architecture of the search implementation that we have. I wouldn't want to take time and explain everything, but I just talk about the search. So we have an existing search engine where we have data indexed using the lexical search. Now, using the generative AI, we want to use more sophisticated search and provide more accurate and relevant results. So here we are using LLM to create and enhance the search index using the dense vector implementations. So that is one thing we were using there. And this is an offline process. We do it during the our initial ingestion process. And then when the user really comes to this UI and tries to do a search, we try to combine both the results, lexical results as well as the semantic and vector results, and try to provide more accurate results to them. And sometimes when we want a little more accuracy and context-specific results, there we are using LLMs to do the query understanding and further expansions. That is one more area where we are using LLM. And the third one is summarizing, because we all know LLM is very good to summarize. So we have used there to summarize the information in a very easy format, and also we have embeddings of references. That is one more thing we have provided. So this is the implementation we have, and it uses the typical RAG architecture. RAG is retrieval augmented generation. So this is enhancing the LLMs. That is what I can say in a simple word. Now I will pick up examples of the generative AI that we have already started working, and some of them in production. The first one is about Scopus AI. Scopus AI, as the name says, it's an extension to Scopus, which is already available in the market. So we have used generative AI there. And what we are using is our existing Scopus content. And this is actually targeted for the early career researchers, because they are very new to research. They do not have the right terminology to search. Because if I take the existing Scopus, it's a lexical-based search. So only if you give a real keyword, you would get the results. That way, they will not be able to get right information. But using this, they would be able to get better information, because we are using the semantic search there, and we are using the RAG architecture and so on. So we provide, what are the features we are providing? We are providing the natural language query, which is simple for them to use, and then we are giving the summaries, and we are also giving them the navigation till the level where they find the relevant information. It's in the beta phase, because I'm going to run the demo where it says alpha, but Alpha was in July, and just 2 days ago, we've released the beta version. Now I will run a small video that gives the demo of the Scopus AI. Sound? There's no sound? I hope you found that interesting. Now, I'll talk about another use case. So this is in the health, and the name of it is Shadow Health. This is in the health education, to be more specific. As I was telling earlier, we had different products, 3D for Anatomy, HESI, and this is the one which we call it as Shadow Health. This helps the nurses who are in the graduation and undergraduation, and they want to get real experience talking to the patients and how to interact and communicate, because they have to have that empathy and they have to understand the feelings of the patient, right? That is very important, so which maybe is missing sometimes. So this helps them to get trained in that area so that there is better like towards the end, the satisfaction for the patients. So that is the way it is. And here, it's, as I said, it is a scripted and simulated 3D environment that we have. But still, there is a communication and interaction they do through ChatGPT. And we have used search-based conversational engines, and we've used advanced NLPs to make sure that the conversations are enhanced and improved. We have used different models there. Again, we've used RAG architecture. As I said, it is scripted. They cannot go beyond that. There is some set of already pre-existing data available, but it's vast. We have 60 unique characters, and based on the answer the patient is providing, there's a question, and so on. There's a conversation that happens. So what are the features? We have 3 features at this point of time. It's simple asking questions to the patient. That is the first thing. And second one is about educating the patient. Like if a patient is asking a question, oh, how is it? What is the reports? What is it diagnosed? And so on. This information is provided. And the third one is empathizing the patient. If patient says, I have pain here, pain there, how to react to that. So these are the 3 things we have. And also, we are doing a lot more there. But we are still in the development phase, and I cannot really reveal all that details here. So this is about the Shadow Health, and I will run a small video.
Hi, Kyle.
Hey.
How are you?
Hey, I'm okay. Having a CF flare. Welcome to my life.
Sorry to hear that.
Thank you. I appreciate it.
When did it start?
I started feeling sick about 2 days ago, just after school. My mom and I tried the usual treatments I use, and I wasn't getting better. That's when we came in.
It was correct to come in.
Yeah, I understand.
That's all. As I said, we are also revising and making the conversation better, taking care of the pronouns, a lot of other stuff which we are doing, which I do not want to talk about it. So this is the second use case. Now the last use case, which is completely different. So I'm trying to give a perspective of different categories where we are working on, and this is about the societal impact. I've showed my mission earlier, organization's mission earlier, where we said that we create an impact to the society. So this is towards that. And here what we are actually doing is, once we receive a lot of this research information, we are tracking all the research data and trying to see how they are making an impact to these sustainable development goals. Sustainable development goals are defined by UN, United Nations. To name a few, they were like no poverty, better education, and also all this related to the, I can't read well, so related to the environment and also the gender diversity. There are many more there. So this is something unique, and Elsevier is providing a solution to organize them with respect to the SDGs. So what happens is, whenever we receive an article, we try to do this organizing them and putting them into relevant buckets, and then this information is passed to one of the ranking system, which is renowned and very much accepted by all the universities, that is called Times Higher Education. So that would be taking this data, and they provide the scores. So using that, there's a ranking given to every university every day, and it's very much important that all the universities tries to get their rankings well defined in this ranking. So quickly, I would say what we are doing there. Once we get the article, we try to exploit the data, like citations and the different keywords from the abstract and so on, and we have different fields, all of them coming in, and we try to train our models so that there is better, accurate, efficient information is there, and using that they can classify these articles. That is what it would do, and also we apply the classification algorithms. So this is the way it works. Again, here also we've used NLP, we have used models and all that stuff. So there are different use cases where we are using these AI and generative AI. That one last down below is showing one of the example where we're talking about University of Manchester, where it scored 94.9 points for the SDG 12. So that shows that they are doing good investment and doing research in these areas. So that's about it, all the 3 use cases that I have. And now I would like to end the session with this one note from our CEO, Kumsal. She says, the research community shapes the future. Let's work together to create a groundswell of inclusion and progress in the scientific endeavor. Thank you.